Good day everyone. My name is Aiki Sitalan from BSMAT 1-B. For this video, I will discuss about statement and logical connectives. But first, let's define the statement. A statement is any declarative sentence that is either true or false. Take note, a statement then will have a truth value. It's either true or false. It cannot be neither true nor false, and it cannot be both true and false. So now, let's determine the following sentences if it is statement or not. The trains are always late. This can be true or false. So this is a statement. Do you speak English? It is said that the statement is any declarative, so this sentence is not a statement. Next is 1 plus 1 equals Magellan. This sentence is false, so it is a statement. I have loved you. This sentence can be true or false, so this is a statement. Compound statement. Some statements are composite, that is composed of subproposition and various logical connectives discussed subsequently, such as composite propositions are called compound statement. For example, roses are red and violets are blue is a compound statement with substatements roses are red and violets are blue. Let's proceed to the logical operators. There are 5 logical operators. The first is the negation, with the symbol of a dash with a tail at the end of it. The second is conjunction, with the symbol like a head of an arrow which is pointing above. Third, disjunction, with the symbol like a head of an arrow which is pointing below. The implication, with the symbol of arrow pointing to the right. And the last one is double implication, with the symbol of arrow with the two head pointing to the left and right. Let's have the negation. The negation of P, denoted not P, is a proposition that is false when P is true and true when P is false, with a symbol of a dash with a tail and the end of it, and the connective is word not or any word that negates a statement. In truth table, it will look like this. Since we need to negate the P, look at the first row in the statement P. If the P is true, we will make it false. If the P is false, then we will make it true. The conjunction. The conjunction of P and Q, denoted P and Q, is a proposition that is true if both P and Q are true. Otherwise, P and Q is false, with a symbol like a head of an arrow which is pointing above, and connective is the word and. In truth table, the first row is both P and Q is true. So P and Q is true. The second row, the P is true, while the Q is false. Since there is at least one false statement, so P and Q is false. Just like in the third row, there is one false, so P and Q is false. Then the last row, both P and Q are false, so P and Q is false. Disjunction. The disjunction of P and Q, denoted P or Q, is a proposition that is true if at least one of P and Q is true. Otherwise, P or Q is false, with a symbol like a head of an arrow which is pointing below, and the connective is the word or. In the first row, both are true, so P or Q is true. The second row has at least one true, so P or Q is true, the same as the third row. The last row, both P and Q are false, so P or Q is false. Implication or conditional. The implication Q of P, denoted P implies Q, is a proposition that is true if Q is true, or if both P and Q are false. Otherwise, P implies Q is false. The implication is sometimes called conditional statement. The symbol is arrow pointing to the right, and the connective is if then. In the truth table, the first row, both P and Q is true, so P implies Q is true. The second row, the P is true and the Q is false, so P implies Q is false. The third row, the Q is true, so P implies Q is true. The last row are both false, so P implies Q is true. Last logical operator, double implication or biconditional. The double implication between P and Q, denoted P if and only if Q, or usually Q if and only if P, is a proposition that is true if P and Q are both true or both false. Otherwise, P if and only if Q is false. Double implication is sometimes referred to as biconditional statement, with a symbol arrow with a two head pointing to the left and right, and the connective is if and only if. The first row in the truth table, both are true, so P if and only if Q is true. The second row, the P is true and the Q is false, so P if and only if Q is false, the same as the third row. The last row, both P and Q is false, so P if and only if Q is true. At last, let's have an example. Write the required statement given the indicated connectives. Statement P, triangle has three sides. Statement Q, triangle has three corners. Number 1, negation of P. Since we need to negate the statement P, so it will become triangle doesn't have three sides. Number 2, negation of Q. So it will become triangle doesn't have three corners. 3, P and Q. So this will become triangle has three sides and three corners. 4, P or Q. It will become triangle has three sides or three corners. Number 5, P implies Q. If triangle has three sides, then it has three corners. Number 6, P if and only if Q. So this will become triangle has three sides if and only if it has three corners. That's all for this video. I hope you learned something from this. Thank you very much.